Good Monday morning. Today we are going to explore the concept of pipelines. Pipes is absolutely not a new concept. It's built into the UNIX command prompt and is very much part of that whole ecosystem and how things work. It's also a language feature and built into the syntax of F#, OCaml, Elixir, Elm, Julia, LiveScript has it as well. There is a proposal to add the pipeline operator to JavaScript, but the pipeline operator really is just some nice syntactic sugar, so you can implement pipelines in JavaScript very easily yourself, and that we're gonna do that today. Pipelines is really not so much a language feature or a technique as it is a way of thinking about data processing, and I want to spend a little bit of time exploring that as well. That is what we're going to explore today. I am MPJ and you are watching Fun Function. Before we do anything else, I just like to quickly show you what the pipeline operator is. In order to do that, we need some kind of an example function. Let's imagine that we have a capitalized function. Oh, we don't need to imagine it because I just pasted it. So this is very straightforward. What it does is that it takes a string, it takes the first character of the string and makes it uppercase. Let me use it for you so that you are completely with me. Capitalize. And I need to say hello, and we echo that out. And it's hello, but with the first character made big. What the pipeline operator allows us to do is to call functions with a single argument in a different way. Alright, so I'm going to, under this, write the equivalent call using the pipeline operator instead. So I do write the string first, and then I write the pipeline operator, and then I write capitalize here, like that. You won't see it executed here because it's not part of the language yet, but that's all it does. This has some implications, and we're going to dive into those in a little bit. But first, I would like to talk in general about functional programming. I've mentioned this before on the show. I feel that the more functional programming I do, the better my habits as a programmer becomes. The thing that I like about functional programming is that it gets to the core of what programming is. I feel that when I'm doing functional programming, a lot of the fluff that is in programming is shaved away. At its core, a computer takes a piece of data and transforms it into another piece of data. And a function, a pure function, a function with no side effects, a function that just takes a value and transforms it into another value and does nothing else, that is a great analog for what computers are. In object-oriented programming, it feels like object orientation is an abstraction of this data transformation, and then there are abstractions made on top of that abstraction, and at some point it just becomes these weird abstract factory bullshit that you're building, and you're so far away from the actual data processing that you just can't reason about it. There's absolutely a lot of abstraction in functional programming as well, and you can do absolutely horrible things there as well. But it feels to me that it lends itself less to do that. It just feels like functional code is closer to the actual concept of data processing. It just, to me, feels more natural to what it is that a computer program does. And as I say this, I realize that it sounds vague. Maybe the examples that we're going to look at will give you an idea of what I'm talking about, and maybe it won't. We'll see, but that is the way I feel, at least, about functional programming. Before we proceed, I would like to bring in two more sample functions. Let me delete this for now and then bring in two new friends. So double say, let me show you what these does. It's just const x, and then double say, and let's just say hello. What does that give us? It gives us hello. And if I do exclaim, and it just gives us hello with an exclamation mark. Because a screencast has a limited amount of space, I would like to refactor these into arrow functions, also because I just like arrow functions. Alright, cool. As you see, when you have these single line functions that have just one argument, it just lends itself very, very well to arrow functions. Oh, I forgot to x that variable. This thing I'm doing where I'm replacing the variable with x in these short functions, that is a personal preference. I really like it, but a lot of people don't. I like it because I feel it is sort of like using pronouns in sentences in English. For instance, if I ask a friend of mine, where did you put the key? He can reply, I put it on the table, instead of saying, I put the key on the table. Oh no, my OCD sense is tingling. These double quotes needs to be replaced with single quotes. There, satisfied. As I said before, programming is a lot about data processing, like transforming data into other data. And it's also about composing things, like making things modular. So these three functions here, oh my god. These hover tooltips, does anybody know how to disable them? What is the flag to disable these hover tooltips? I have tried to find it, I just can't, I feel so dumb. Anyway, let's try not to trigger that. Alright, so let's bring this back to pipelines. These three functions here, they are these small isolated components, like modules of logic. This is the nice thing about functional programming, when you have these isolated parts that we can compose. And by compose, I mean that we can use them together in different ways, even though they are not at all aware of the existence of each other. The reason why we can compose them is really just that they are very simple and that they are pure. Okay, so let's just double say this thing first, and then we also capitalize that. And then we exclaim it. And it says, hello, hello. And this is the way functional programming is supposed to feel. Like, it's just these small little parts that are very simple, that just slot together. And this works because the function is a very simple contract. It just takes some values and it returns a value, and it does very few things. If these were classes with complicated interfaces coming from different sources, it just wouldn't work to do this. It works because functions are simple. However, when you look at this, it just feels a little bit unnatural. We should not try to write code that looks like English, but it's kind of nice if it reads in a way that feels natural. If I say this out loud, I go exclaim, capitalize, double say hello. It's kind of weird because the way we are saying it is not the actual way it's being executed. It would be more natural if the code actually read like what is happening in the order that it's happening. So it would be better if it said something like, take hello, and then double say it, and then capitalize it, and then exclaim it. Because that is what is happening. So let's write a pipeline function. Pipeline. And we want it to look like this. We want it to have want to take the functions in sequence, and then exclaim, and then we would like to call it with hello. So what we want pipeline to do is to return a new function that has composed these three functions into a new function, a pipeline, that just takes a value at the start and then just pipes it through all of these functions and returns whatever comes out at the end. I'm not sure how to go about this. Let's say function pipeline. And pipeline should take some functions, I guess. And we wanted to return another function that takes the value that we want to transform. Perhaps we can we do this recursively? That would be fancy. Let's see. Funcs. Take the first function and then call it with the value. Nah, there is a time and place for recursion, and I think that this does not lend itself super well. Let's just do a 4. And we're going to call the function with the value, and we're going to do create a value for last computed, last result. I'm going to assign that there, and now we want to call this with last result. No, like this, last result or the value, and then we want to return the last result. I think, did that work? I think it did. My god. So as you see here, having a pipeline function, having access to that, makes it a little bit more natural to write these things. We can now read the code from left to right, top to bottom. Like the first thing that happens is that it double says, then it capitalizes, then it exclaims. We still have the hello at the end, but it's still a bit better. By the way, we don't have to write these pipeline function. I just wrote it right now because I wanted to show you that there's not much magic involved. You can instead use a functional library like Ramda. We're going to do that. Const r require Ramda. And then we can use R pipeline instead. Isn't it pipeline? Is it just pipe? Oh, it's pipe. And then I can remove this. While we are at it, I just wanted to show a little bit of the power of composition, because these things are capitalized. That feels like a very general thing. It feels like general to humanity. These things seems specific to our application, but this, maybe there is a library that has this. It's just the const require lodash. Oh, hang on, I need to import that. Create integrated terminal, npm install lodash. Close that. All right, now we have lodash. And instead of using this capitalize, we just use the capitalize of lodash. Hang on. And I can now delete capitalize, and lo and behold, it still works. And again, the reason why this works so seamlessly is that these functions are very simple. They are both simple in the sense that they are just plain functions. They are not a classes with some specific interface that you have to instantiate or anything. They are just a plain function that takes a value and returns a value, and it does very few operations on it, and it doesn't have any side effects. It's just a very simple transform function. Capitalize here is just a plain, simple, pure function, and that makes it remarkably reuseful and composable. The more skeptical of you might be thinking right now, okay, but these are all functions that take a single argument. How does this play with functions that have multiple arguments? So let's do that. Let's say that there existed a function that was called it's just const append, and it appended a character. So it's the generic version of exclaim, but you can append any character. So it has two arguments. It has the string and it has the it has the character and it has the string. So it takes the string and it appends the character. That's what it does. So that we replace this with append char mark and then the string, and then we have hello hello. And now we imagine that exclaim does no longer exist. We just have append char, which is a function that takes 2 arguments. We can't just paste that in because that becomes super weird. So how do we provide append char with this first argument? Well, this is where arrow functions comes to the rescue. And I'm going to do x, and I'm going to do append char, exclamation mark, and then x. That's the way you do it. Some examples like to use Lodash for this. Like, oh, now it becomes really confusing that this is named Lodash. Let's just use the proper name of the library. There. Likes to use the Lodash as the variable name. I'm not sure what I think about that. It kind of makes it look like a form that hasn't been filled out, which I like, but I'm more of an X kind of guy, I think. Let's delete this exclaim function. We no longer need it. So perhaps now you are seeing like why pipelines is an interesting way of programming, or perhaps you don't and you have left. What the pipeline operator does is allow us to do this in the language without writing our pipeline function or without pulling in a library like Ramda. Having it built into the language also slightly nudges people towards this way of programming because it becomes slightly more accessible, and it also, putting it into the language, gives it a certain sign-off as well to do it. But either way, let me show you what it would look like with the pipeline operator. Let's remove Ramda, and we're going to take hello, and we're gonna put it at the start. And then we're going to write a pipeline operator. We're going to take double say, put it after a pipeline operator, write a new pipeline operator, take Lodash, capitalize, put it here, then going to write third pipeline operator, and we're going to take the final one and put it there, and then we're done. So these are showing up as errors because this feature does not exist yet in JavaScript. It's just a proposal. But this is the syntax that the proposal is suggesting. It also happens to be the syntax in many of the functional languages that uses this. And let me paste in the Ramda example so that you can compare them side by side. I think that this syntax is very nice. It shows very clearly that we are taking hello, and then we are piping it to double say, and then we are piping that value to Lodash capitalize, and then we're piping that value to this function, which appends the character exclamation mark. I like this proposal a lot. One could, of course, have many objections to this. For one thing, it adds yet another thingamabob to the JavaScript specification, yet another thing in the language, making it slightly harder to learn. Then on the other hand, I see like very far gone proposals to add things like private properties to classes, and I think that since we're pulling in stuff from the object-oriented languages, I think that it's not an unhealthy thing to pull in features, really good features, from solid functional languages. Functional programming is not the end-all be-all of programming, but I think that it's safe to say that we are looking as an industry a little bit too much at object-oriented programming and a little bit too little at functional programming. I think it's healthy to pull a few functional features in. What do you think about the pipeline operator? Write a comment That is it for today. You have just watched an episode of Fun Function. I release these every Monday morning, 0800 GMT. If you don't want to wait until next Monday morning, you can check out this machine learning surprise that YouTube has selected for you. I am MPJ. Until next Monday morning, stay curious.